Hey everyone, welcome back to The Explainer. Today, we're diving into something that is literally an absolute game changer for your code. If you've been on the hunt for a definitive C++ STL tutorial, well, you hit the jackpot. We're breaking down the core concepts from Lecture 39 to help you truly master STL in C++. Look, mastering the standard template library in C++ isn't just some nice-to-have skill. It's a total lifeline. We're going to unpack everything you need to know about STL containers and figure out exactly how to wield algorithms and iterators in C++ to make your development insanely fast. So let's jump right in, shall we?
So, picture this. What happens if you walk into a high-stakes technical interview, you've got C++ proudly stamped on your resume, but you try to get through the coding rounds without using STL? Honestly, it's basically a nightmare. Interviewers 100% expect you to know this stuff inside out. Ever since it rolled out in C++ 98, it's been the absolute bedrock of modern development. Trying to code complex data structures entirely from scratch while the clock is ticking? Yeah, no way. You'd just be wasting precious time reinventing the wheel instead of actually solving the problem they gave you.
Right, so let's look at why that is. Before this library came along, programmers were basically living in the dark ages of manual coding. On the left here, you'll see traditional static arrays. They're fixed in size. If you wanted a dynamic structure that could grow or shrink on the fly, you had to manually wrangle new and delete keywords, build custom classes from the ground up, and write these agonizingly long algorithms just to do basic stuff like deleting a node. It was tedious and super prone to bugs. But then, look at the right side, modern STL efficiency. You get ready-to-use generic structures that just dynamically resize themselves. It's kind of like building a car engine from scratch every time you need groceries, versus just turning the key and driving off. To really nail down how this feels, think about making dinner. On the left side, you're boiling the potatoes, mashing them, grinding the spices, doing every single bit of the prep work totally from scratch. That's manual C++ coding. But on the right, you've got ready-to-cook frozen tikkies or, pre-made dosa batter. You just grab it, heat it up, and boom, you're cooking. STL is exactly that. It's pre-cooked code. You get to skip all the exhausting redundant prep work and just dive straight into building your software. Okay. Let's ground this with a quick formal definition. The Standard Template Library, or STL, is this incredibly powerful library packed with a massive collection of ready-to-use generic classes and functions. They are custom-built to handle complex data structures and algorithms super efficiently. But here's the absolute best part, the reason developers are so obsessed with it. It handles all the dynamic memory allocation internally. As the programmer, you get this completely seamless experience. You aren't stressing about background code or manually freeing up memory. You just use the structures, and STL handles the heavy lifting behind the curtain.
Section 1. The anatomy of STL, the 3 pillars. So, to understand how this actually works under the hood, check out this table. Think of this as your high-level map to the whole library. There are 3 pillars, and they work together perfectly. First up, containers. These are the actual data structures holding your collections of data, like vectors or maps. Second, we've got algorithms. These are the inbuilt functions that manipulate that data, stuff like sorting and searching. And finally, iterators. These act as the bridge, helping you navigate smoothly from one piece of data to the next. Let's break each of these down a bit more.
Starting with containers, this is basically the heart of where your data lives. They're dynamic structures. The most famous one, and honestly the one you're going to use all the time, is the vector. Think of a vector as a dynamic array. Unlike those clunky old static arrays, a vector seamlessly grows or shrinks at runtime as you add or remove items. It keeps your memory allocation continuous, and, this is huge, it gives you random searches in O of one time. Plus, right out of the box, you also get other awesome containers like lists, stacks, queues, dequeues, and maps for storing key-value pairs. But hey, storing data is really only half the battle, right? Once your data is in a container, you actually have to do something with it. That's exactly where our second pillar, algorithms, steps in. STL doesn't just hand you a container and say, good luck. It gives you ready-made, inbuilt functions that you apply directly to your data. Need to sort a massive list or maybe search for a specific value? Count occurrences? You really don't need to write out that long manual code anymore. You just call the STL algorithm and it handles it efficiently. No reinventing the wheel required. And that brings us to the third pillar, iterators. Because you might be wondering, how do these algorithms actually talk to the containers? Well, through iterators. You can think of them sort of like smart pointers. When you're dealing with a massive amount of data stored in a vector or a map, iterators give you the power to traverse and navigate smoothly from one element to the very next.
They are the bridge that lets you travel through massive data collections safely and effortlessly. Section 2. Bridging Theory to Reality. Real-world applications.
All right, abstract concepts are cool and all, but connecting this theory to reality is where things get really interesting. This isn't just trivia to pass an interview. This is literally how modern software is built. Take vectors, our dynamic arrays. Picture an e-commerce shopping cart. The number of items is constantly going up and down as users add or remove products, right? A vector handles that dynamic resizing flawlessly. What about lists? Well, they act as doubly linked lists, making them absolutely perfect for media playlists on apps like Spotify, where you constantly need to skip forward or backward. And priority queues? Operating systems use them heavily under the hood for CPU task scheduling, instantly figuring out which critical tasks to run first and which ones can wait.
Ultimately, the whole thing really boils down to this quote from our source material. STL is a one-stop solution for easily implementing data structures and their associated algorithms. I mean, it really is the ultimate toolkit. It saves you tons of time, it helps prevent those nasty memory leak bugs, and it lets you focus on the actual logic of your problem, instead of getting bogged down in the tedious plumbing of data management. So as we wrap up this explainer, I want to leave you with a question to chew on. How much time have you already wasted writing redundant, manual code that STL could have handled for you in literal seconds? It's definitely time to leave the dark ages behind. Now that you've got a solid grasp on the massive power of the standard template library, you're perfectly set up for our next explainer, where we're going to dive deep into the most important container of them all, the vector. You absolutely won't want to miss it. Keep learning, keep coding efficiently, and I'll catch you in the next one.